Hello everyone and welcome to Global Update channel. Today I invite you to take a journey back in time. Let's go back to 1970. In March of that year, the prestigious neurosurgeon Robert J. White performed an extraordinary operation. In a hospital in Cleveland, USA, White successfully connected the head of one monkey to the body of another for the first time. The surgery lasted 18 hours, and when the monkey woke up, it could see, hear, smell, and even bite. The news caused a sensation. We can say that this was the first successful brain, or rather head, transplant. White was not the only one to attempt this, but he was the most notable. He is credited with developing numerous surgical procedures that are still used today to save lives. However, his work was also heavily criticized. He was branded as the standard bearer of the crude and cruel vivisection industry, which possibly thwarted his Nobel Prize aspirations. Despite the incredible advances in science, we still haven't been able to transplant the brain. The problem lies in a significant issue. No one has managed to connect the new organ to the spinal cord of the recipient body. In White's experiments, the monkeys were paralyzed from the neck down. This would explain why his candidate was quadriplegic. In that sense, he had nothing to lose. Considered by some to be the most complex object in the universe, the brain establishes millions of connections that control all the functions of our body. Reconnecting all this network with the necessary precision to restore the circuits is still beyond our reach. Moreover, if we could transplant it, what would happen to our memories, emotions, and everything we have learned? These are not trivial questions since, and we can all agree on this organ holds the key to our identity. Since it's not yet possible to successfully transplant the entire brain, perhaps we can moderate our expectations and help it in its astonishing capacity to remodel itself. Resilience allows us to adapt to difficult circumstances and overcome adversity. Our brain continuously adapts to environmental conditions, modifying the connections between its neurons, forming new ones and eliminating others. This faculty is known as plasticity, and explains why we can learn to solve a mathematical equation, remember the name of a good wine, or discard memories that no longer serve us. It also allows us, in some cases, to recover from a brain injury. But brain plasticity has a downside. It can mask diseases like Parkinson's or Alzheimer's, which go unnoticed for years or even decades as the brain struggles to compensate for the progressively damaging effects. However, we have discovered that this is not the case. Our brain contains stem cells that generate new neurons every day. This process is known as neurogenesis, and its discovery has revolutionized neuroscience. Unfortunately, this capacity persists only in very specific regions of the adult brain. One of these areas is the hippocampus, which is involved in learning and memory. But we have good news. The creation of new neurons can be stimulated. Exercise or foods rich in antioxidants, for example, promote this renewal process. We also know that obesity, aging, or neurodegenerative diseases hinder it. Therefore, stimulating neuron formation to regenerate the brain has become an exciting challenge for science. Although this intervention has been tested as a possible treatment for various neurological diseases, I will talk about the one I know best: Parkinson's disease. This disease is characterized by the death of neurons that produce dopamine. Their absence creates chaos in the brain circuits, leading to problems, primarily motor issues. To try to repair this damage, neuron transplants that produce this important neurotransmitter have been performed. The results have been excellent in laboratory animals and a good number of patients who have seen improvements in their symptoms. But these are only experiments. Before making the definitive leap to clinical practice, we need to solve a series of problems. We need an accessible source of neurons, since until now they were obtained from fetal tissue with its inherent limitations. Thousands of these cells are required to replace all those that have died in a patient, and millions if we consider the number of affected individuals. In this regard, stem cells offer great opportunities. We must also ensure that neurons survive after implantation, and if that were not enough, connect correctly with their neighbors. There's no chance of getting bored with so much to do. At this point, brain regeneration capacity may not yet meet your expectations, but trust in science, which, like the brain, is an expert in resilience. Thank you for joining us on this fascinating journey through the history and future of neuroscience. Don't forget to subscribe to the Global Update channel, like this video, and activate the bell to not miss our next content. We'll see you next time.